In traditional cloud computing, the scaling formula is simple. If a network slows down, you add more servers and you immediately scale capacity. The hardware works together to process more data at higher speeds. Blockchain networks suffer from the exact opposite dynamic. Through a phenomenon known as the validator paradox, adding more nodes to a decentralized network actually slows the entire system down. This counterintuitive punishment for growing larger puts a hard limit on global adoption. When expanding the network reduces throughput, mass-scale operation becomes impossible. We see the consequences of this limit in the current market. It causes Ethereum's high gas fees during spikes, contributes to Solana's outages, and keeps Bitcoin at a constant 7 transactions per second. The cause is a computer science principle called Amdahl's law. It states that a system's speed is restricted by its sequential bottleneck, the part of a process that must happen one step at a time, represented as an S value greater than 0. In traditional blockchains, this bottleneck is global state synchronization. To prevent double spending, every transaction is pushed into a single file line. Validators must coordinate and verify every transaction sequentially. As activity increases, this coordination overhead causes a massive traffic jam that slows execution. You cannot solve a sequential bottleneck by throwing more hardware at it. As long as that single file requirement exists, legacy blockchains hit a mathematical ceiling at global scale. SynapticChain removes that ceiling using an S=0 architecture. It is designed to eliminate the sequential bottleneck from the execution process entirely. It uses compile-time parallelism. The network's compiler analyzes every transaction and maps out all state dependencies in advance, identifying potential conflicts before the code ever executes. Instead of forcing traffic through a single tollbooth lane, SynapticChain pre-sorts these isolated transactions into perfectly parallel highway lanes. Because the network has already determined these transactions will not conflict, they require no runtime coordination. The lanes flow simultaneously without interfering with one another. Removing that coordination overhead allows blockchain scaling to mirror traditional computing. By engineering out the bottleneck, SynapticChain links validator count directly to total throughput. We can see this scaling curve in action by looking at the empirical data gathered during SynapticChain's April 2026 testnet burst tests. The test used consumer-grade hardware to isolate a single shard processing 400 transactions. This chart maps throughput over time. While the legacy network flatlines near 15 transactions per second, SynapticChain cleared all 400 transactions in 154 milliseconds, a measured rate of 2,597 transactions per second. The system achieved an exact 20x parallel speedup by utilizing 20 unique transaction lanes without a single collision. These measurements move the conversation from theoretical modeling to empirical proof. The test data confirms that the network scales predictably by adding processing lanes, showing a direct link between validator resources and throughput. On the user side, a zero bottleneck architecture changes the experience of interacting with a decentralized application. This bar chart displays finality times across different ledgers. While Bitcoin takes minutes and Ethereum takes seconds, SynapticChain demonstrates a microscopic sliver. A live VRF coin flip application on Telegram recorded network finality in under 500 milliseconds. The efficiency gains are measurable. Executing these operations on SynapticChain was 18,000 times faster than Bitcoin, while operating at a cost 1,000 times lower than Ethereum. Combining sub-second finality with near-zero fees makes it possible to run high-frequency, complex enterprise applications directly on-chain. The Synaptic Consensus Protocol addresses the core limitation of decentralized architecture. By mapping dependencies at compile time, SynapticChain ensures that adding validators expands the network's total capacity rather than increasing its coordination burden. You can verify the data yourself. Visit synapticchain.xyz to read the technical white paper, test the live network faucet, and review the production-ready code. The sequential bottleneck limiting the entire industry is finally broken. The future of distributed consensus is completely parallel.